Welcome to the deep dive. Today, we're plunging into something huge, something that, well, powers literally everything we do, mostly humming away silently in the background.
The energy grid.
Exactly, the energy grid. And you might think it's just the stable giant, but honestly, right now it's caught in what you could really call a perfect storm.
That's a good way to put it. You've got this massive push for renewables.
Right, which are great, but, intermittent, volatile sometimes.
Mm-hmm. And then there's this explosive growth in demand. Think about data centers, EVs.
It's almost insatiable. And layered on top of all that.
Extreme weather.
Yeah.
More frequent, more intense events, putting incredible strain on the whole system.
And for you listening, this isn't just some abstract problem. The impact is real. It's costly.
Oh, incredibly costly. When this infrastructure falters, the ripple effect is just immense. I mean, think about it. Power outages alone, they're estimated to cost the U.S. economy something like
Don't tell me.
a staggering $150 billion every single year.
Wow. That's an eye-watering figure. Really hits home.
It's a direct hit to businesses, essential services, just our daily lives.
Which really highlights how urgent these challenges are. So that's our mission for this deep dive. We want to explore a really novel, cutting-edge solution that's tackling these fundamental issues head-on.
Yeah, we're going to unpack how one team is confronting the grid's core challenges, these twin challenges of, well, complexity and uncertainty.
And they're doing it by merging physics-informed AI with quantum-inspired optimization. Sounds complex itself.
It is advanced stuff. We're talking about a company called Qubit Engineering. Their approach aims to make our energy infrastructure, frankly, much more robust and intelligent, more reliable for everyone.
Okay, let's unpack this idea then, this dual challenge, complexity and uncertainty. When you say complexity for the grid, what does that actually look like? What does it mean?
Well, what's truly fascinating here is just the sheer scale we're dealing with.
Right.
Imagine tens of thousands of individual assets. You've got giant power plants, miles and miles of transmission lines, countless substations.
Doesn't interconnect.
All interconnected, yes. And they all need to work in perfect harmony in real time. That intricate coordination, managing every single piece to keep the power flowing, that's the inherent complexity. It's like a massive, constantly shifting jigsaw puzzle.
Okay, I can picture that. And the uncertainty part, that sounds maybe even trickier to get a handle on.
It is,
Yeah.
in many ways, because it's driven by things that are, well, fundamentally unpredictable.
Right.
Like, picture a sudden sharp drop in solar power output because a big storm cloud just rolls in unexpectedly.
Okay.
Or an unexpected huge spike in demand, maybe an extreme heat wave hits, everyone cranks up their air conditioning at the same time.
Right, things you can't perfectly schedule.
Exactly. And current grid management systems,
Yeah.
they often struggle precisely because they weren't really built for this level of dynamic, real-time unpredictability on top of that huge complexity we just talked about.
They just can't react fast enough sometimes.
They can't adapt quickly enough, yeah.
So Qubit Engineering comes in with this two-part solution for that two-pronged problem. Let's start with the uncertainty piece. They call it Neuro-Grid.
That's right, NeuroGrid.
And you mentioned physics-informed AI. That sounds different from standard AI. Can you walk us through what that means? How does it tackle the unpredictable?
Yeah, this is where their innovation really shines, I think. See, unlike a lot of purely data-driven AI models, which can sometimes be a bit brittle, if they see something totally new.
Something not in the training data.
Exactly. NeuroGrid is different. It's built directly on the fundamental laws of physics, the actual rules governing power flow.
Okay, so it's not a black box guessing.
Not at all. It inherently understands the underlying physical principles of the grid, and that's key. It means it can make remarkably accurate, reliable predictions, even in scenarios it hasn't explicitly seen before.
Like those extreme weather events.
Precisely. It gives grid operators a level of confidence they just didn't have with older systems. For the utility partners, this basically translates into an incredibly detailed, high-fidelity, real-time map.
A map of what's happening right now.
Right now, yes. And crucially, what's likely to happen next. It essentially answers both the what is happening and the crucial what-if questions.
Okay, so NeuroGrid gives that critical foresight. It's like a highly accurate crystal ball, but grounded in physics for the grid.
That's a good analogy, yeah.
So then how does QuantiGrid, their second module, take that foresight and turn it into action? into managing that huge complexity we talked about. Where does quantum-inspired optimization fit in?
Right. So once NeuroGrid lays out those operational scenarios,
Yeah.
the what if this problem occurs or what if this new demand appears.
Okay.
QuantiGrid then taps the immense complexity of figuring out the best course of action.
Best course, like what specifically?
Well, it could be anything from instantly rerouting power flow to optimize it, prevent overloads, or even proactively scheduling critical maintenance to fix potential issues before they cause an outage.
And I read something interesting that Quanta-Grid doesn't just spit out one single optimal answer. That sounds like a really big deal.
It absolutely is. It's a huge leap forward, honestly. Because in the real world, right, a single optimal answer, well, it might not always be feasible.
Why not?
Other operational constraints, maybe specific goals the utility has at that moment, things the purely mathematical optimum doesn't account for.
Makes sense.
And just to be clear, this quantum-inspired part, it doesn't mean they need some giant quantum computer running things.
Ah, okay. Good clarification.
Yeah, it refers to algorithms that borrow principles from quantum mechanics. This lets them process and optimize these huge, complex data sets much, much more efficiently than traditional computers could.
So it's like a smarter way to search for solutions.
Think of it like a super intelligent search engine. Yeah. It can explore billions of potential solutions almost simultaneously. And here's the key difference you mentioned. It identifies multiple distinct pathways, multiple good solutions.
Which gives the operators choices.
Exactly. It empowers the utility operators. They can evaluate these different viable options and select the one that genuinely fits their specific needs right then and there. It offers a level of flexibility they've just never really had before.
So it's about better tools for human decision makers, not replacing them.
Precisely. Empowering them with superior data and options.
This sounds like incredibly deep, complex technology. Groundbreaking, really. Developing this, especially for something as critical and complex as the grid, must have taken a massive amount of R&D effort.
Oh, absolutely. It certainly wasn't an overnight success story.
I bet.
Their journey involved years of really focused R&D, just diving deep into some of the toughest optimization problems in the whole energy sector. They spent their formative years basically developing and then hardening their core algorithms, making sure they could actually stand up to the messy, intricate physics challenges you find in the real-world grid.
So building that really robust foundation first.
Exactly. A foundation that could handle pretty much anything thrown at it.
And that foundational work, it sounds like it wasn't just about theory. It was critical for proving it works in practice, for commercial viability. Are they actually working with major players already?
Absolutely. Yeah, this isn't just tech stuck in a lab somewhere.
Yeah.
They're already involved in direct collaborations with major utilities, people like the Tennessee Valley Authority, for instance.
Okay, TVA, that's significant.
And they're working closely with research partners, too, like Oak Ridge National Laboratory.
Here.
So this practical application, this validation out in the field, it's crucial for proving their capabilities.
Yeah.
And, if we connect this to the bigger picture for a second,
Yeah.
the market opportunity for these kinds of advanced grid solutions is just, well, it's enormous.
How big are we talking?
The U.S. smart grid market, just that piece, is projected to hit nearly $100 billion by 2030.
Wow. Nearly $100 billion.
Yeah, that really gives you a sense of the scale, right, and the urgency people feel around finding effective solutions to modernize our energy infrastructure.
So what does this all mean then for how a company like Qubit Engineering tackles that massive market? What's their actual business model? How are they planning to scale up?
Well, their model seems pretty well designed for enterprise adoption by utilities. It's quite straightforward.
Okay.
Basically, there's an annual license fee. That gives access to both the NeuroGrid and the Quanta-Grid platforms.
Makes sense. Software license.
Right. Then there's a one-time deployment fee that's for integrating their solution into the utility's existing systems.
Integration costs, yeah.
And finally, an annual support fee that covers ongoing help from their technical teams, ensuring smooth operation, updates, all that.
So predictable recurring revenue plus initial setup?
Exactly. And they're actually raising capital right now, a seed round, specifically to boost product development significantly.
Making NeuroGrid and Quanta-Grid even better.
Yep, enhancing capabilities.
Wow.
And also to rapidly expand their commercial teams, get this technology out to more utility partners across the country.
So it's a clear sign they're serious about building a scalable business, not just developing, cool tech in isolation.
Absolutely. It's focused on real-world deployment and growth.
So just to kind of bring it all back together, Qubit Engineering, they're really a deep tech company tackling this multi-billion-dollar grid management market head-on. They've got this validated two-pronged approach we discussed, NeuroGrid, using that physics-informed AI to really get a grip on the grid's uncertainty.
Tackling the what if.
Right. And then Quanta-Grid, leveraging that quantum-inspired optimization to manage the sheer complexity, finding those smart, flexible solutions.
Dealing with the scale and the interconnectedness.
It's a really compelling example of how advanced tech is being applied to solve some of our most fundamental infrastructure challenges today.
Indeed.
Yeah.
It really offers a powerful glimpse into, well, the future of energy management.
Yeah. And it makes you wonder, doesn't it? If we can achieve this level of resilience, this intelligence, in something as vast and critical as our energy grid, how will that not only prevent those incredibly costly and disruptive outages we started with, but how might it fundamentally change how our societies actually function?
That's a big question.
Think about the unforeseen innovations it could unlock, right?
Yeah.
The new technologies it could power, the truly sustainable energy future it might actually help enable. That's a profound thought for you to consider next time you flip a switch.